Let's see how to find the best model using the validation data, then save the model using PyTorch. In this video, we will cover: first, let's create some artificial data in a dataset class. The class will include the option to produce training data or validation data. We can plot out the data. The training data includes outliers. We create a custom module for linear regression. We create our criterion, our train loader object. We create our model. We create an optimizer object. We can save the model for use as follows. The input is the model's state dictionary. The second input is the name of the file we would like save as. This example is a little elementary, so let's save the model after early stopping. We will need a minimum loss value that we will use to compare different loss values. Let's perform early stopping for each iteration. We have reviewed the training step. Let's focus on the following lines of code. For the first iteration, we calculate the loss or cost. The value is 200. In this line of code, we will check if the value of the loss is less than the previous iterations. If so, we will record the epoch, update the minimum loss value, and save the model. We compare the value of the loss to the previous smallest loss value. The value of the loss is larger. The value is false. We do not update the values and save the model. We compare the value of the loss to the previous smallest loss value. The value of the loss is smaller. The value is 50. We calculate the loss or cost for the next iteration. The value is true. As a result, we save the model. We repeat the process for the rest of the iterations. To load the model, we will create a new linear regression object. We will use the parameters saved in the early stopping. The model must be the same input dimension and output dimension as the original model. We then load the trained parameters using the function loadTorch and loadState_dict. In the lab, we can see that the model using early stopping in blue is a much better fit to the data points in red compared to the model that used maximum iterations in orange. Sometimes, we would like to save our model during training and stop where you left off. In this case, you need to save more than just the model. You also need to save the state of the optimizer, epochs, loss, etc. You would do it like this. In this case, we repeat all the same steps as last time, but for this example, we will only use training data. We have the checkpoint and file name. We create a Python dictionary. This is called the checkpoint dictionary. It contains the epoch number, the model state dictionary, the optimizer state dictionary, and the loss value. In this code, we train for 4 epochs. At the end of each epoch, we save the required information. The following lines of code trains the model. Then the following lines of code save the information we require to continue the process. Let's take a closer look. We store the epoch number, the model state dictionary, the optimizer state dictionary, the loss value. We save the results in a .pt file. We can resume training. We can load the checkpoint dictionary using torch.load. This loads all the information we require. We create a linear regression object. We can see the parameters are randomly selected. We load the state dictionary from the checkpoint dictionary into the model. The model parameters have changed. We create an optimizer. We need the state from the training session, so we load the state dictionary. This changes the optimizer to the state in the last training session. Finally, we load the loss. We can then resume the training.